Here is a nice problem. We have to find all possible oblique asymptotes of this function y equal to x power 2x power 3 by 2 plus 2x minus 3 by under root x plus 1. Right. The highest power of numerator is greater than highest power of denominator. Obviously, when x tends to infinity, this y also will tend to infinity. But the question is not that. The question is about oblique asymptote. Okay, is there an oblique asymptote for this? Okay, so we can write this 2x power 3 by 2. What is this? This is actually 2x into x power 1 by 2, which is nothing but 2x root x, right, plus 2x minus 3. This numerator, which is nothing but 2x times root x plus 1 minus 3. Right, this numerator is that. What does that mean? This we can write it as 2x times root x plus 1 by root x plus 1 minus 3 by root x plus 1. We can do it like this also, or even if we do polynomial division, we will still get the same thing. Basically what we are trying to break this function into two parts. 3 by root x plus 1. Okay. There is a difference of 1 within the highest powers of the numerator and denominator, right? This is half and this is 3 by 2. So obviously 3 by 2 minus half is 1. So numerator is 1 power higher than the denominator. That means there is an oblique asymptote, right? We already discussed this. Oblique asymptote is when the numerator has got 1 power higher than the denominator. So that means we can break it as one linear equation plus something else. Okay, this is a linear equation. Now when x tends to infinity, what will happen? This one will become very, very small, right? Because 3 by root x plus 1, right? And x is so big, then 3 by this thing will actually become insignificant, and 2x is the one that dominates, right? So we are talking about some 2x minus something positive. When x is small, this positive quantity would be big enough, but when x becomes very, very big, this number becomes closer to 0. So minus a small number, 2x minus small number, right? And this number will keep going smaller and smaller, and the graph will try to approach this 2x graph, right? So it looks like this. I'll show you the graph also. So we know the line 2x, right? When it is 2, it should be 4, and when at 4 it is 8, when at 6 it is 12, whatever. The line joining this and 0, this is our 2x graph, right? This is our line y equal to 2x. Now, as x increases, these parts will keep going smaller and smaller. That means this graph of this will keep approaching 2x. So this green line is the graph of this function. It will keep approaching this line y equal to 2x. It can never cross 2x, right? Because this part, however small, it is still positive. It can approach 0 only. It can never cross 2x. 2x minus something, whatever small it is. So that's why 2x is the oblique asymptote. This 2x is a linear equation, right? And this graph will try to approach 2x, but it will never touch 2x, and it will get closer and closer to 2x, right? So when x becomes very big, when x is very small, what will happen? When x equal to 0, what will happen? This is 0, and minus 3 by root 0 plus 1, minus 3, that is this point, right? When x equal to 0, this is actually this point, and before 0, so because there is a root x here, right? X negative, it is not even there in the domain. So this graph is applicable only when x is greater than or equal to 0, and when x becomes very big, this approaches this line y equal to 2x. That's why this line y equal to 2x is called oblique asymptote. Oblique means slant. Otherwise, we know about vertical asymptotes, graphs like this, or we know about horizontal asymptotes, graphs like this, right? So this is oblique asymptote, where this graph is trying to approach this line, but it will never reach. It will always fall short by the small amount. This amount will keep going smaller and smaller, right? 2x minus something. So this small amount is always shorter, but this amount will keep getting smaller and smaller. So that's why it will try to reach 2x. 2x is the oblique asymptote, right, guys? Hope you understood this. Thank you.